So once you detected the object, each frame is a new frame to you. So you want to continue the identification. I'm basically a moving object, but you know in your brain that this picture is still Tom Zimmerman. He just moved a couple millimeters to the left. Same thing with your algorithm. You're going to have to, frame by frame, keep track of objects. And that's called tracking. You have to consistently have the same ID. Even though you don't know the creature's name, you give it a number. And from frame to frame, it has to keep that number. That's successful tracking. And once you've tracked an object, think of like ballet or dance. You're now moving, you have a moving target now. You're making these tracklets, these traces of where they've been. So now you can do things like figure out how often they turn, how fast they're moving. The other thing you know is when you have a movie of something, you're seeing different poses. If you just take a picture of me, you see the front of my face, and then you see here's the side profile. Basically, when I'm doing a movie of something that's moving, you're getting multiple views, point of views. And so if you're successfully tracking an object, if you think about it, each of these dots is a picture you took of it. And since you know it's the same creature in this tracklet, each of these images is a different point of view of that creature. And that'll be really important in classification because here's a bottle. I don't know if you can see this, right? It's long and narrow. Here's the same bottle. Now it looks like a circle. This will really confuse machine learning algorithms because this is the same object, but it looks dramatically different based on its poise, its posture. So that's something else we'll have to consider when we do machine learning. Okay, so that's detection, tracking, and segmentation. And so the holy grail, as I mentioned at the end of the day, is to classify these creatures.